All right, welcome back. What we are going to be doing today is talking about negative exponents and zero exponents and those properties. We have already covered the product and quotient properties, and these kind of fall right in line with those two. So the first thing that you're going to want to know is the property for negative exponents. So for every non-zero number a, an integer m, then you have a to the negative m power equals a divided by a to the m. And a cannot be zero. So you should know this because you're not allowed to divide by zero. Remember, the whole world will try to explode thing. It doesn't make sense to say how many groups of zero can you put into one. It doesn't make any sense, okay? So you can't divide by zero, but any other number will work. So in other words, if there is a negative exponent, like negative m, flip its location. So whatever base it's attached to, say it's on the top of the fraction, just move it to the bottom to make it a positive exponent. If your negative exponent is on the bottom of the fraction, bring it to the top to make it positive. So I have two examples at the bottom. We have x to the negative third. We're not combining that with anything right now. We're just rewriting it to make the exponent positive. So this right now is actually the numerator. So x to the third is actually the top of a fraction right now. Remember, you can divide everything by 1. So we just said, all right, let's take this, x and negative 3, and bring it on down to the bottom to make the exponent positive. So notice how x to the third is now at the bottom of a fraction, and all that's left over is a 1 on the top. The reason being because of the invisible 1 that you can put in front of any variable here. So this is actually 1x to the negative third. We brought the x to the negative third down, but the 1 stayed on the top. So that's how we got that answer. I also gave you the flip option. So x to the negative third is already on the bottom. So to make it positive, we just bring it up top. And then again, if you want that 1 in front, go for it, but it's not actually necessary. But there's nothing left on the bottom anymore because the x to the negative third got moved up to become positive. The second property you're going to want to know is on 0. So for every non-zero number a to the 0 power equals 1. Again, a cannot be 0 here. So this one's actually pretty simple. It's the easiest one out of all of the properties because anything to the 0 power is 1. So I have two examples down here, but you could use literally any number, any variable, anything of that sort. So 5 to the 0 is 1. Negative 2006 to the 0 is 1. X, Y, Z to the 0 power is 1. So anything to the 0 power, just get in your head, that's 1. I have a little bit of an example here to show you why exactly everything to the 0 power is 1. So you should already know these types of concepts. Something like 3 squared is 3 times 3 in expanded form. 3 to the first power, that's the same as 3. And then it's going to make sense on why 3 to the 0 is 1. So the same reason why you can put 1 in front of any variable holds true also for any number. So say I put 1s in front of all of these numbers here. So instead of 3 squared, we have 1 times 3 squared. So we have 1 times 3 squared here. Well, that's still 3 times 3. I mean, if you wanted to, you can still do 1 times 3 times 3. I can put as many 1s as I want in here because multiplying by 1 doesn't change anything. I can also do it down here. So 1 times 3 to the first power is the same thing as 1 times 3, which is still 3. I can do the same thing down here. So 1 times 3 to the 0 power, well, taking something to the 0 power, that's really just saying we don't have any 3's. Up here, this means we have 2 3's being multiplied. So we wrote those down. 3 to the first means we only have 1 3 being multiplied. So it's just chilling by itself. 3 to the 0 means we don't have any 3's at all. So if we get rid of it, it's completely gone. Then what's left? The number 1 is. That's actually why anything to the 0 power is 1, because of those floating invisible 1's. So anything works that way. Let's look at some examples. These ones are negative exponent examples. Let's see, only the exponent and its base will actually move if you have a negative exponent. Anything else next to it will stay in its normal location. So in this problem over here, 2x to the negative third, well, x is the only thing that actually has a negative exponent attached to it right now. The 2 is not a part of that. The x is the base, the negative 3 is the exponent. So that is what I am going to move. Since it's technically right now floating on the top of a fraction, we're just going to go ahead and bring it right on down to the bottom. The 2 will stay on top. When that happens, we get this answer. So x to the third, it's a positive 3 now is on the bottom, 2 on the top. This one here, I wouldn't worry about the negative yet. Do what you already know how to do using the quotient property. So we have a 4 and a 2 being divided, so that will get us 2. And then we have an x squared and an x to the negative fifth being divided. Those are like bases, which means we can actually divide them. And our quotient property says subtract your exponents. So this is actually 2 subtract negative 5. Now think about that for a second. What is 2 minus negative 5? You'll notice that it is actually a positive number. There's no movement necessary here. We got rid of the negative just by using our quotient property. In this third one, we have multiplication going on here. So we do not deal with the negative yet. Do your multiplication steps first. So 3 times 2 is 6. And then we have m to the negative second power times m to the sixth. Those are like bases. And whenever you're multiplying like bases, you add your exponents. Negative 2 plus 6, again, you're going to notice you get a positive exponent when you do that. This final one down here, do the same process. Do your division step first, then wait to see if you have any movement necessary for negatives. So 12 divided by 4 is 3. R to the negative 1 divided by R to the negative 4. So that is negative 1 take away negative 4. So think, what does that get you? Is it positive? Is it negative? You should find out that it is a positive 3. Negative 1 take away negative 4 is a positive 3. So we did all of that and we didn't actually have to move anything. So let's look at some examples where we actually are going to have to move some stuff. So first here, there are a few different answers that you could get for this, but we have 5 divided by 5, which is technically 5 to the 0 power, but we talked about this. Anything to the 0 power is actually 1. So 5 divided by 5 is 1, and then m to the negative 6 divided by m to the second power. Negative 6 minus 2 is negative 8. So we still have a negative here, and you got to go, well, is this on the top? Is this on the bottom? So I'm going to try and break this down for you in just a moment. So we just got 1m to the negative 8 power. So think, all right, is that the top or the bottom of a fraction? Well, 1m to the negative 8, that's the top of a fraction. So to make that a positive exponent, go ahead and bring it to the bottom. So this is just like one of our first examples that we did. We just moved the negative exponent with its base and left everything else on the top. This one here, we have 12 divided by 6. That's 2. And then n to the negative third divided by n to the negative 2. Negative 3 minus negative 2. And that's going to give us kind of a strange number, so think about it for a second. Actually gets you a negative 1. So we have 2n to the negative 1 power. We don't want a negative exponent, so go ahead and move its location, bring it to the bottom. You'll notice here that I didn't actually write the exponent 1. It's not necessary. Just like it's not necessary to put a 1 in front of a variable, it's not necessary to put a 1 as an exponent. It's up to you. The third example that we have here, we have 4x to the negative fifth. There's only one thing that we have to do here. There's no multiplication or division. We have a negative exponent attached to x. So go ahead and take both of those, the exponent and its base, and shift it on down to the bottom. 4 stayed in place. Now we have multiplication. So do 12 times 3. That's 36. Then we have the x's that we can combine, x to the -1 times x cubed. Whenever you're multiplying like bases, you should add your exponents. -1 plus 3 is 2, so you should get x squared. Y to the 4th times y to the -5th. 4 plus -5 is -1, just like what we got up here with this problem. So we have y to the -1 power. We do not want a negative exponent, so bring it on down to the bottom. Same concept, you can put the 1 here, but it's not necessary. Then lastly, if we want to write this in exponential form, so we have 2 and 2. They are common bases, so leave them as 2. But then think, what do we have to do to our exponents? Since they're being multiplied together, our bases are being multiplied, we add our exponents. -3 plus -2 is -5. So we have 2 to the -5th. Again, we don't want negative exponents, so we're going to bring that 2 to the -5th to the bottom of the fraction. Nothing really is left over, so the only number that you can put on top is a 1. All right, lastly, I kind of have a mix of these two things, so negative exponents and zeros. So the first one, we have 24 to the 0 power. Remember, anything to the 0 power is 1. In our second example, we have 3 multiplied by 2xy squared to the 0 power. Well, all of this, everything in the parentheses here is being taken to the 0 power, which means all of this is going to turn into 1, which means this really is what is 3 times 1, which is just 3. In our third example, we've got a multiplication process. So we can do 5 times 5, which you could say is 5 squared because we have like bases. If you write this as 25, I will accept that as well. Then we have x squared times x. So think, how many x's do we have in total here? We have 2 of them being multiplied here, and then we're multiplying a third one over here. So that's x to the 3rd power. And then we have y to the -2nd power and y to the 1st power over here. So -2 plus 1 is -1. Can't have negative exponents, so bring it on down to the bottom. Our fourth example, we have m to the -3rd times m to the 3rd. Well, we're multiplying our bases, so add your exponents. -3 plus 3 is 0. So we have m to the 0 power, which again, anything to the 0 power is 1. The final one for this lesson, 16r to the -4th divided by 2r. 16 divided by 2 is 8. R to the -4th divided by r, well, we're dividing our bases, so subtract your exponents. There's an invisible 1 right here. -4 subtract 1 is -5. So we have 8r to the -5th power, but we don't want a negative exponent, so bring that r to the 5th to the bottom of the fraction. And that's all we have for today. I know it seemed like a lot, but I wanted to make sure I gave you a variety of examples. Make sure you come prepared with any questions you may have tomorrow. Best of luck.